Hi, welcome to Introduction to Aerodynamic Objects Tutorial 9, Aircraft Design. And in this tutorial what you're going to do is reconfigure an existing conventional aircraft into a canard configuration. We're going to verify our control setup using simulated wind tunnel tests, and then we're going to demonstrate successful free flight. So here we are in Unity. We're at the endpoint of tutorial 8. We've just finished our conventional aircraft and got it flying with our flight controls. And what we're going to now do is some scrap heap challenge to try and reconfigure this as a canard aircraft. And in the process we're going to show how easy it is to do aircraft design with aerodynamic objects just by moving stuff around. Okay, let's build a canard aircraft. And to start off with, what we're going to do is just start moving things around. So if we go to the wing, on a canard aircraft the wing is at the back and the tail's at the front, so let's just move the wing back. I'm going to grab the horizontal tail, drag that to the front. Propeller's going to get in the way there, so let's put the propeller on the back. And since we're going to be a bit short of space at the back there, I'm going to make the propeller a bit smaller. So I'm going to simply do that. I'm going to do a universal scale. I'm going to scale it down to 80%. And if you notice there, everything moved. The aerodynamic objects, the blue reference area is all scaled by 0.8 as well. So we can just literally scale an object and we rescale the aerodynamics as well. Fin's in the way there now, so let's move the vertical stabilizer out the way. So let's put it on the wingtip. That'll do, and duplicate it because we want one on the other side as well. And just change the sign of that as a quick way of flipping it to the other side. Okay, we've got ourselves a canard aircraft of sorts. So let's do some basic testing to see how this is going to work. We're going to start off with our static test as usual. I'm going to grab the aircraft and just move it up a little bit so you can see what's going on. Let's fix it in space. So this is our static wind tunnel setup. Let's check what our wind speed is. Currently it's on 5. Because we've turned the sensitivity of the arrows down, I'm going to move that up to 10 meters a second. That's closer to what it might fly at. Let's turn off the turbulence. And since we're working in the game view, we're going to be using our orbital camera again, so we need to configure that so that it works how we want. So if we go to our aerial orbit camera, we can leave the settings we had before, but we don't want auto orbit. Let's give that a go. So I'm going to hit F2 to go to the orbital camera. And we can see there that our wing is at 0 angle of attack. We've got plenty of wind, we can see on the windsock. But we notice that actually just in terms of the basic balance of the aircraft, there's no lift on the wings, but we've got a down force on the foreplane. And that foreplane was set at that angle because previously it was at the back, and that's how we balance the aircraft. Now it's at the front. If we've got any lift on the wing, we need a lift force on the foreplane to balance that. At the moment, what that's going to do is push the nose straight into the ground when we've got nose lift on it. What we want that to do really is lift up the nose. So just from eyeballing it, we can see that the angle of that surface is going the wrong way. So let's fix that. If we go to tail, horizontal stabilizer, tailplane geometry, and it was at -5 before, so we can just flip the sign. Simple as that. So we're doing this in play mode. All the aerodynamics is handled for you. So our surface has gone the other way, and we can now see we've got a happy positive lift on the front there. So in this circumstance, if it really was flying along wing 0 angle of attack, the nose would get lifted up by the foreplane, and then this thing would start generating lift. Let's quickly make that permanent by coming out of play mode and changing that to 5. Go back into play mode. And let's test our controls out. So F2. Let's try the wings. Because we've only moved the wings back, we shouldn't really need to do anything. So that's left aileron, yeah, so that's the right wing picking up. Right aileron, left wing picking up. So that's good. Rudder. Only one rudder's working. We could fix up both. We just duplicated it, but we haven't duplicated in code sending the control inputs there. Really doesn't matter. One rudder's good enough for this aircraft. The rudder's working the same way. We haven't changed that. But if we go to the foreplane, if I pull back on the stick, so back arrow, we can see the control surface goes up and we get negative lift on the front. So if I pull back on the stick, the front of the aircraft would dive towards the ground, and that's not what we want. So we need to reverse the sign of the elevator gain. So simple to do, we go to our aircraft, find our aircraft manager, and if we look at the pitch control gain, which is what the elevator uses, we just need to change the sign of that to a minus. And now when I pull back on the stick, we get more lift, so the nose would raise. Push down on the stick, the nose goes down. Great, let's make that permanent. So aircraft manager, pitch control, minus 0.5. Okay, so far so good. We've completely changed around the aircraft, but with a few simple changes to control surface gain and the angle of the tailplane. We've got an aircraft that balances and in theory does the right thing. Next up, let's try the dynamics. So we're going to release the aircraft from its fully rigid state and just allow it to move around the centre of gravity. Notice we haven't moved the centre of gravity. It's exactly where it was before in the other aircraft. Let's try that. Okay, so that's not bad. If that was flying, we've got a bit of lift on each of these wings. It's being balanced out by the lift on the floor plane, but that aircraft would fly. And so I've got some roll control, and I pull back on the stick. We get more lift, so I'll trim at a lower speed. Push down on the stick, you get less lift. Trim at a higher speed or even upside down. So actually, without doing very much at all, we've got an aircraft that is obeying what it should do for a controllable and stable aircraft. Kick in some rudder, swings to side. Okay, so pretty happy with that. But one thing I do notice is that it's actually not very responsive. So I'm pulling full elevator on and it doesn't actually change very much. And the reason for that is the aircraft is probably too stable. So our centre of gravity where it is too far forward in the sense that it's very stable, but we can't do much to alter the trim position. So let's move the centre of gravity back to try and make it a little bit more agile. So if we grab the centre of mass marker and let's just move it back about there. Try that. Okay, now if I pull back on the stick, it moves quite a lot more. It's actually trimmed at a higher incidence when I let go. It's actually flying at a slightly higher angle of attack. But that's a bit more agile. It's probably what we want to make this thing a bit more sporty. We can change the trim angle of attack by a lot more. Okay, well let's keep going. How can we make it really, really sporty? Let's move the centre of mass back even further. Let's move it back to about there. And cameras, I'm going to set default camera as orbital. Oh, okay. So I think we've overcooked it there. As soon as we we hit play, immediately pitched up, and I can just about control if I'm doing some very active control. Well, I lost it there. It's gone unstable. So if we had a flight control system on there, probably the aircraft would be just about flyable, but just by a human pilot on the keyboard, that's too unstable. So what we've seen there is that is too far back the centre of gravity, so let's just move it forward to about where it was before. So back there. Still trimming at a bit of a high incidence, so what I'm going to do just to make the trim at a slightly lower speed, I'm just going to knock that down to 3 degrees. So it doesn't sound much moving it by 2 degrees, but when you're configuring an aircraft, rigging it, a 3 degree setting between the wing and the tail, moving things a couple of degrees is quite significant. And that looks happier, so it's flying at an incidence of sort of 3 degrees or so now. Okay, good. So we've got our aerodynamic balance and stability, but we've obviously still got a design issue in that our ground balance is not going to work. Well, let's just try it, see what happens. If we take off the constraints and turn the wind off, we guess what happens if we let go. So that would have been okay if this undercarriage position, if we'd had an engine on the front. Clearly with an engine on the back it's not going to work. In fact, we could just try, oh, there we go, actually. So made a sort of a bit of a kangaroo plane, but clearly the propeller would have broken, so that's not very satisfactory. We need to sort our gear out. We need a tricycle sort of gear here for this, but we got away with one set of gear for the puller configuration, but in a pusher we really need two sets of gear. So what we're going to do is select our undercarriage, and because we're lazy we're just going to do Control D to duplicate it and move it back. So let's put it around there. Okay, it doesn't quite look right. They normally have a single wheel at the front, so it's unusual having four wheels on a plane, but that'll do. Let's just see what happens now. Okay, I can live with that. So it's when you drop it, it tips back just because of the inertia, but it settles down to the right angle. So I think we're ready to go flying. Some things we need to do. Let's set our camera default to ground view, and let's not drop the aircraft quite so much when we put it into the world. We can drop it a little bit. And the pilot looks a bit uncomfortable sitting there, so I'm just going to move him back to sitting on the centre of gravity. And bear in mind, the pilot doesn't contribute anything to aerodynamics or mass and balance. He's there for us, so something to look at. Okay, let's give it a go. Okay, going down the wrong way, but actually, even on full thrust, we've not really got enough speed for takeoff. So what's happened there is that we've made the propeller 80% smaller, but we haven't increased the maximum speed it can go at, so we're not getting enough thrust. So let's go and change that. So the maximum RPM was limited to 100. We've made the propeller 80% of its size, so let's actually increase that to 150, so it's spinning around faster. And whilst we're here, let's reduce the size of the arrows on the propeller by a factor of 5. Okay, so we've adjusted our engine management system, so our engine can spin a bit faster now, so hopefully we'll get enough thrust for takeoff. Okay, here we go, going up to full throttle. Okay, that's much better. Pulling back on the stick, yeah, and we're away. And there we have it. We have a canard configuration aircraft made by rearranging a conventional aircraft, and there's nothing in the laws of aerodynamics or Newtonian physics that says a plane like this is any different to a one with a tail at the back. It's just a case of getting things balanced and making things stable. So that flies really nicely. We did a little bit of moving stuff around, changed a few gains, but in reality it's fairly simple once you've got an aircraft configuration to use the Aerodynamic Objects to build anything you like, experiment with designing your own aircraft. Fantastic. So that brings us to the end of the introduction to aerodynamics tutorials. We started off by making some wind, then we made a weather vane and then a wing, and then we turned the wing into a basic glider. Then we made a propeller Then we added some flight controls, and finally we've seen at the end here how you can mix and match things to produce your own aircraft. So if you made it to here in the tutorials, well done for getting to the end, and hopefully that started you off on a journey of making your own things fly.